Alright, good evening class. Today we're going to take some notes on absolute value, and the definition of absolute value is the absolute value of a real number x, and it's written as absolute value of x, the two bars, is its distance from 0 on the number line. So for example, the absolute value of 3 would equal 3. If we were to draw that on a number line, and I have 1, 2, 3, here is 3, I am 3 units from 0. This is 3 units. Alright, if I wanted to say the absolute value of negative 4, if I draw that on a number line, 1, 2, 3, 4, I am still 4 units from 0. So that is positive 4. So an absolute value will never be negative. It'll always be a positive. So let's say that I have something that I know the absolute value of x is equal to 5. Alright, I know that if I look at that, I'm looking for some value that's going to give me, I look at the number line here, 0, 1, 2, 3, 4, 5. I'm going to be here, because this is 5 units from 0. Okay, and then I can also be here at negative 5, because this is 5 units from 0 also. Alright, so then that's going to tell me that x is going to equal 5, or x is going to equal to negative 5. Again, because the absolute definition of absolute value is the distance away from 0. So positive 5 is 5 units away from 0, as is negative 5. It's also 5 units away from 0. Okay, so we're going to look at our first example of solving an absolute value equation. So the first example is, what is the solution of the absolute value of the quantity 2x minus 1 equals 5? So keep in mind, I'm looking for some value that's going to give me 5 units away from 0. Okay? So remember that we have to look at the positive side and the negative side. So we have to look at two things. So first thing you're going to do is you're going to set up the two equations. I want to know what value is going to say 2x minus 1 equals positive 5. And the answer is going to be 2x minus 1 equals negative 5. Okay, so you solve these like you do a regular linear equation. So the first example here, I'm going to add 1 to both sides, and I wind up with 2x equals 6, and then you divide by 2, and I get x equals 3. So that's the positive 5. So let's see if I can get a negative 5. Here I add 1, and I get 2x equals negative 4, divided by 2, and I get x equals negative 2. Alright, so now I have two solutions for x, and I want to check both of them and see if they both solve the original equation. So I'm going to go back in, I'm going to check these. I'm going to say, okay, so if x is 3, 2 times 3 minus 1 equals 5. 2 times 3 is 6 minus 1. So the absolute value of 5 equals 5, and 5 does equal 5, so that is a check. And we're going to do the other answer. So I'm going to have 2 times negative 2 minus 1 equals 5. And then so 2 times negative 2 is negative 4. Negative 4 minus 1 being negative 5 equals 5. The absolute value of negative 5 is 5 equals 5, so that is a check. So we were going to draw the solution on a number line. I know that if I had these, I would have 0, 1, 2, 3. I would draw my solution there on that number line, and at negative 2. So these are my solutions. Okay, so we're going to do another example. This is a sample of a multi-step absolute value equation. So in order to, before we can do anything, we have to have the absolute value isolated. So this is saying, what is the solution of 3 times the quantity of the absolute value x plus 2 minus 1 equals 8. So again, we have to isolate the absolute value before we can set up our two equations. So I'm going to go ahead and add 1 to both sides here. So I have 3 times the absolute value of x plus 2 equals 9. And now I'm going to divide both sides by 3. So these cancel. And I have the absolute value of x plus 2 equals 3. So remember, when we talked about our definition, we talked about the absolute value of x equals 5. Remember up here we talked about this notes here. And I knew that x was going to equal positive 5 or negative 5 because they both give me equal distance away from 0. So I need to set this up to the two equations. So I'm going to have x plus 2 equals the positive 3. And then also we need to do x plus 2 equals negative 3. So if we solve, we have two simple linear equations here to solve. We would subtract 2, and I get x equals positive 1. And then subtract 2, and I get x equals negative 5. So after we have our two values, you want to plug them back into the original equation and check them out. So I'm going to have, let's check 1. We have 3 times 1 plus 2 minus 1 equals 8. So we follow order of operation. The absolute bars are like parentheses, so we do inside that. So this would be 3 times the absolute value of 3 minus 1 equals 8. The absolute value of 3 is 3, so 3 times 3 is 9 minus 1, and I get 8 equals 8. So that checks out, so that's a good solution. I do the same thing here. I have 3 times the absolute value of minus 5 plus 2 minus 1 equals 8. So I have 3 times the absolute value of negative 3 minus 1 equals 8. So 3 times negative 3 would be okay, so the absolute value of negative 3 is 3, so 3 times 3 is 9 minus 1 is 8, so 8 equals 8, and that's a check. And if I want to graph these on a number line, I know that my solution would be x equals 1, and draw a circle at 1, and then at x equals negative 5. So those are my solutions to that problem. Okay, example 3, we're going to look for checking for extraneous solutions. And what an extraneous solution is, it's a solution derived from the original equation that is not a solution of the original equation. So remember how we have to set these up to positive and negative. Sometimes we're going to set those up, and then when we go back to do our check, it's not going to give us the right answer. So that would be an extraneous solution. So let's go ahead and work example 3 and to demonstrate this example. So we have the absolute value of 3x plus 2 is equal to 4x plus 5. So again, we set these up, so this means that I'm going to have the absolute value of 3x plus 2 is equal to 4x plus 5. And then also I have to look at 3x plus 2 equal to negative 4x plus 5. Okay, we'll have to distribute that negative, so that will give me 3x plus 2 equals negative 4x minus 5. Alright, so again, we have two simple linear equations that we need to solve. So I'm going to solve the one on the left on first. So remember, you got to combine your like terms. So I need to get my x's on one side of the equation, equal sign, and then constants on one side. So I'm going to start by subtracting 3x here, minus 3x. Okay, these cancel. I'm left with 2 is equal to 4 minus 3 is just x plus 5. Subtract 5, and I get negative 3 equals x. Okay, so that's one solution. So I do the same thing over here. I'm going to subtract 3x minus 3x, cancel out here, and I wind up with 2 is equal to negative 7x minus 5. I'm going to add 5 and add 5, and I get 7 is equal to negative 7x, divide by negative 7, and I get negative 7. divided by negative 7 there, I'm sorry. And then 7 divided by negative 7 is negative 1 equals x. So my two solutions here are x equals negative 3 and x equals negative 1. So this is when we have to go back in and we need to check our solutions. So I'm going to do my little check here. So let's start with x equals negative 3. So I go back to the original equation. So I have the absolute value of 3 times x would be times negative 3 plus 2 is equal to 4 times x. So I'm going to put negative 3 in for that plus 5. Okay, so the absolute value, 3 times 3 is negative 9. So negative 9 plus 2 is equal to 4 times negative 3 would be negative 12 plus 5. So negative 9 plus 2 is going to give me the absolute value of negative 7. This is going to give me negative 7. The absolute value of 7, negative 7, is 7, and that is not equal. Okay, so that is not equal to negative 7. Okay, so in this case, negative 3 looks like it's going to be an extraneous solution. Let's check x equals negative 1. So we're going to check x equals negative 1 here. Alright, so I go back to the original equation, which is the absolute value of 3x, which I'm going to put in negative 1, plus 2 is equal to 4 times negative 1 plus 5. Okay, so the absolute value of 3 times negative 1 is going to be negative 3 plus 2. And then 4 times negative 1 is going to be negative 4 plus 5. The absolute value of negative 3 plus 2 is negative 1. And the absolute value, and then negative 4 plus 5 is 1. The absolute value of negative 1 is 1. And then 1 equals 1. So negative 1 is a good solution. So I would know that negative 1 is the correct solution to this, and that negative 3 is an extraneous solution. Okay, guys, on the back at the end of your notes, there are 3 examples. As you try, I want you to try 1, 2, and 3 on your own. Finish those up from your notes. On the first one, you want to look at example 1 on your notes, example 2 for number 2, and then on number 3, you need to look at the example 3 with the extraneous solutions. Don't forget to do the Google form, the Google Doc at the end, and I will see you tomorrow. Have a good night.